Okay, we have here today another interesting integral from the UNSW Integration Me CPMS 2023 Round 2 Problem 8. We have the integral of x squared minus 1 over x squared plus 1 times the square root of x to the fourth plus 1 dx. Okay, at first this one was really hard to deal with because there's no apparent u substitution. If you do trig substitution right away, it's kind of a mess, and it wasn't clear how I should factor this. But the one thing that stands out is we have all these, we've got x squared here and x squared here, and we've got x to the fourth here. And it turns out this is a good place where we can use like 1 over x or 1 over x squared. So I'm going to start with the denominator, and for this one right here, for x to the fourth plus 1, I can factor an x squared out of this, and then we can write this as x squared plus 1 over x squared. And then for this one right here, what I'll do, I'm just going to factor an x out of this, so we end up with x times x plus 1 over x. And so now I'll go ahead and I'll rewrite this. For now, we'll keep this x squared minus 1 in the numerator. Then we'll have this first piece, x times x plus 1 over x. Now we have this x squared inside the square root, so I'm going to take it out of the square root as just another x, but I can multiply it times this, and we have an x squared here. So then inside the square root, we'll just end up with x squared plus 1 over x squared. But now what I'm trying to do is set up a u substitution. So what I want to do is let's take this and factor this again. What I can do is we can write this as x plus 1 over x squared. If you square that out, you get x squared plus 1 over x squared, which is this. But then we'll have, with the middle terms, we'll have a plus 2. Well, we don't want to change it, so what I can do is subtract off 2. And now this here is the same as this here. But now before I continue from here, let's just notice that we have this term in common now. We have this x plus 1 over x here, and we have this x plus 1 over x squared inside the radical. So when I'm moving towards the u substitution, I'm going to want that to be my u in the denominator. So we'll have our u equal to x plus 1 over x. I'll take my derivative. So then our du is going to be, derivative of x is 1. Derivative of this is going to be minus 1 over x squared. So now we'll try to set this up. And what I want is, I want this to be my numerator. Well, we've got x squared minus 1. What I can do is factor an x squared out of that. For the first term, we're going to have a 1, and then the second term is going to be our minus 1 over x squared. We'll have our dx, and so this piece here is exactly our du. Then rewriting the denominator, we'll have this x squared, x plus 1 over x. Then here we'll have square root of this thing over here. But now the x squareds are going to cancel out to give us some simplification. And now this is in good shape for this u substitution, because again, we have this du in the numerator. So rewriting this, we'll have our du here. This thing out front here is going to be just u. Then inside the square root, we're going to have, this is just going to be u squared minus 2. And now this morning when I did this on paper, I couldn't decide which method I wanted, so I did it 3 different ways. The first way I did was trig substitution using secant for u. That's kind of the most standard, right? Because then you could almost jump right to an answer in u anyway. The second way is hyperbolic trig sub. That came out really nice when we got our solution in terms of arctan. And then the third way is just a regular u sub. And what I chose was number 3. And I think I chose this just because it gave me a clean solution that looked more like what's in the answer key. So we'll continue from here with our u sub method. Okay, from here we'll do our substitution. Actually, we already used u, so I'm going to do t. I'm going to set my t equal to the radical expression, square root of u squared minus 2. And from here, I think we'll just take a derivative, so we'll end up with dt. Derivative of this is going to bring, if we look at it as half power, we'll have 1/2 u squared minus 2. And then this will be minus 1/2. And then with chain rule, derivative of the inside is just going to give me 2u. 2 is going to cancel here with the 1/2. Don't forget a du right here. Then I can rewrite this. I can write this as u over the square root of u squared minus 2, but that's just t. So we'll have this like u over t du. So just solving for du, we're going to have du equals t over u dt. So now just go ahead and we'll make this substitution. So for my du, we're going to end up with t over u dt. And then all this stuff, we're going to have another u here. This u squared minus 2, this is just our t. So the t's are going to cancel, and we're just left with the u squared in the denominator. But now to get a u squared value, that's pretty easy. If I just square both sides on this, we end up with t squared equals u squared minus 2. Adding 2 on both sides, we end up with u squared equal to t squared plus 2. And now to get it all into one variable, we'll have our dt here, And then for our u squared value, we're just gonna have t squared plus 2. But I can write this 2, just rewrite it as square root of 2 squared. But for this, we can just use our arctan formula. And so solving this in terms of t, we're gonna have 1 over this value, which is square root of 2, arctan of t over square root of 2. But now before I back substitute, let's get t in terms of x. So going back to our u value, if we square this again, this was x squared plus 1 over x squared plus 2. But we have the minus 2 here. So this t value is actually going to be the same thing as square root of x squared plus 1 over x squared. So now I'll just back substitute with this value in order to finish this off. And so for my final solution, we have 1 over square root of 2, arctan. We'll write this as 1 over square root of 2. And then we'll have this value, which is just square root of x squared plus 1 over x squared. Put a plus c there, and that's it. Okay, so there you have it. Pretty messy problem with a bunch of substitution. So we'll stop it there. Thanks everyone for watching. Have a great day.